Thank you, Brenton, for this opportunity to join you again. The entire conference looks really exciting, and there's so many cool new technologies being demonstrated showing where 3D printing is going. What I'd really love to do with this is take the opportunity to kind of step back just a little bit, sort of pull back up to the 10,000 foot level and really start asking the question, where is this all going? What is this technology enabling? And just really where we'll be going, from a business standpoint as we move forward, and what sort of changes will 3D printing be enabling in the future. So let's go ahead and get started and take a look at a lot of interesting example of what's going on today, as well as some new cutting edge things that are going to be going on in the near future. Let's start off by taking a look at a sequence of different steps that are often in place when new technologies are being adopted. Very often when we get going with a new technology and it becomes available, we start out by really taking a look at how we can do things very similar to what we've done in the past, but do them more efficiently. So it's all about optimization. How can we be using this new technology to do things faster, to do things less expensively? But it's really all about focusing on just taking what we're already doing and just doing it better, doing it more efficiently. And it's a very common starting point as we're just really starting to get familiar with the technology and understand what it's going to be good for. As we move ahead and get more familiar with the technology, we often move on to the point of thinking about really what can we do now that we didn't used to be able to do. So given the foundation of understanding the technology, what new opportunities are opened up? What sort of new things can we do that we weren't able to do in the past? How we can expand? What sort of new business opportunities are there? Just how can we go ahead and use it to do things that were never available in the past? And then finally, we actually get to the point where we start thinking about, now that we understand how to use this technology, what does it fundamentally change about the game? What's the strategic business opportunity here? And really, what sorts of new opportunities are being enabled by that technology? So again, we're going to hopefully look at several different examples that will illustrate that point. That'll actually show us some lessons about where it's going. So let's start out with the whole notion of really, how can we do this better? The optimization side, some examples from the world today that just really illustrate how we're applying 3D printing technology to do some of these things. So a real common application that I'm familiar with, I tend to come at things from the civil engineering and architectural side, is just the world of construction and the impact we're having there. So clearly in that world, 3D printing is having a very big impact in terms of being able to rapidly prototype things, test out different design options, and even now moving into prefabricating different assemblies. Construction's always been a very complex spatial thing in terms of trying to get all the sequences of operations in order to make the assemblies fit together. And 3D printing is allowing us to move beyond looking at that on paper or even on computer screens to really understand how to fit things together before we're out in the field. That's a huge savings to that industry. So construction's been very radically impacted. Another aspect, though, of design that's really quite interesting to me is this whole notion of architectural preservation and restoration. And I love this example. This is actually a building done by Frank Lloyd Wright here in the US. It uses textile blocks. And the interesting application of 3D printing technology today, along with scanning, is to go through and be able to replicate those blocks. So there's 46 different unique designs. It was incredibly expensive to try and recreate these, but by using a combination of 3D scanning and 3D printing, they're actually able to create molds to recast those blocks and restore this building. So it's just a really interesting application of the 3D scanning and printing technology working together. And I think we're going to start seeing a lot more of that. This whole notion that really the combination of scanning, either doing it with laser scanning or with photographs, and pulling those together to create 3D models and then be able to 3D print things really gives us that replicator, that science fiction device that is so powerful that gives us a much more cost-effective way of recreating things that are necessary that we'd like to preserve. Okay. Here's a very different application. I just wanted to share this. I'd like to kind of look at examples from different industries. This is from the world of medicine, and really looking at, there's this whole notion of how we can use 3D printed models to help really understand different parts of the human body, to use that to very accurately fit prosthetics, to fit implants into a scan of someone, so we could really understand and get a very custom fit to every individual's body, and then actually plan out the whole process, as well as explaining that to the people who are going to have these installed, really what the whole process is going to be like. So again, having these physical artifacts and be able to work with them is really radically improving the whole world of medicine as just a way of explaining what's going on. So things like skull implants, if we're going to be doing some sort of work on the face, dental implants. We're doing an awful lot of use of 3D printing now to go through and prototype these things very rapidly, kind of field test them before we actually go through and work on the human body, which is sort of a much safer way of approaching it. Okay, another application I really like, though, that's kind of, again, drawing from a different area is just really thinking about history and how we explain history. So the whole idea of large-scale city models is something that's very interesting to me, too. So there have been a couple of really interesting models created of the Forbidden City, as well as of San Francisco. But there's a very interesting one that's just been done of St. Petersburg that I think is really kind of cool. It has over 16,000 square feet and over 1,000 buildings in it. So a huge number of pieces were created using 3D printing, as well as milling and laser cutting to create just a whole full size. And you sort of get a sense of it there from the picture, just how big this model is. And it's really just sort of an incredible historical and cultural resource to be able to have these to explain just sociologically the historical development of cities and have people understand. So I'm just a big fan of using 3D printing technology in this way. The amount of handwork that would be able to create that was just enormous, very cost prohibitive, and 3D printing is just making it more accessible. So those are some examples of kind of what I'll call optimization, or doing things that are really driven more by efficiency. I'd like to switch now to actually think, okay, given that we can do things more efficiently, what are we actually doing differently? What is 3D printing adding to the picture? What can we do now that we couldn't do before? And that's what I call augmentation. So I think there's a lot of really interesting examples there. Okay, one thing that's really changed about the world of 3D printing is the whole notion that we can now actually get into doing full-scale 3D printing. So it used to be we were limited to things the size of a MakerBot, the size of, a few square feet, very small kind of prototypes of things, but now we can actually do full-scale printing, and these are still relatively expensive. 60,000 euros is not anything that most people have lying around, or 79,000 is still very expensive, but it's opening up the door. It's the beginning of something where that cost will come down, these will become more readily available, and we can actually produce things that are more on the scale of 1.5 meters cubed, which is really starting to get to be very sizable for creating full-scale things. So the notion of actually 3D printing full-scale furniture or art objects is becoming a reality. And that's something that's, I think, a very big development. Okay, another very big development from the world of manufacturing that I like is the whole notion of really how we're going ahead and moving from doing prototyping to actually doing real-world production. So what you'll see is here, NASA, so the space agency here in the US, is actually going through and creating manufactured assemblies. What they're doing is it's actually rocket fuel injection systems, and these systems have an incredible number of very intricate parts. Over 163 separate parts would have to come together. By 3D printing, they're actually able to print a full assembly. So incredibly accurately and with great reliability go through and create these incredibly complex objects. It's reducing the cost and actually reducing the chance of failure. So it's a huge boon for that industry. And to do this, they're actually working with liquefied metal powder. I thought that was kind of interesting too. So this whole notion that we're working with resins and plastics is really radically changing, or stone-like materials. The idea to be able to use laser melting to actually melt metal into place to create true cast objects is really opening up the door to kind of a whole new area. This is an application I really like too, so I wanted to share that this is the whole notion of really applying kind of 3D printing to brain surgery. So the idea is we'll go ahead and take a scan of the brain and create a 3D printed model. Okay, but it's not just to sort of fit things into. What I think is so interesting about this, it's really to actually start prototyping not the object, but a process. So the fact that a surgeon can go ahead and, from scans of a brain, go through and create a model of the brain, so before we actually get to the dangerous point of opening up a human body and working in place there, we can plan out in great detail and anticipate and familiarize ourselves, is again, I think, making a huge radical change. And sort of how we're going to be approaching surgery, because we sort of dry run things as a process. Another application that I think is really very fascinating. This is one that I'm very familiar with because Autodesk did this, and there's an exhibit on it in our gallery here. It has to do with reality capture of museum artifacts. So what you'll see going on there's laser scanning going on of a mummy sarcophagus. Okay, and the idea is we can scan these things. We can scan museum artifacts using photos. We can scan them using laser scanning or CT scanning. And from these, we can create models that then allow people to either visually explore, to slice and dice and dissect and actually understand that object in a non-destructive way, in a way that's readily available to people around the world. So as opposed to a single artifact, you have these artifacts available to everyone to actually see, enjoy, and learn from. Okay, as well as to create 3D printed copies of the artifacts. So as opposed to having that one that's in the Smithsonian or in a special museum, to actually be able to print out these artifacts and have them at several locations around the world in various scales or in classrooms for people to learn from. Again, it's a really radically changing, because we have 3D printing available. So those are some examples of augmentation, but I really want to get to the whole notion of transformation, because that's really the issue of where is this all going? What's the strategic business opportunity, and how is this really going to fundamentally change how we're able to approach different business opportunities? So here's what we have in mind. So there's several examples. Again, I'll start with construction just because that's the world I'm from. The whole notion of 3D printing houses is actually becoming readily available. So the notion of printing these fiber cement houses, 10 of them in 24 hours, is pretty interesting. Be able to kind of extrude that fiber cement material, kind of create these truss-like or wall-like objects that are filled voids. Very, very interesting. These homes that they're producing there aren't really very interesting architecturally, but the idea that I can print houses, 10 of them in a single day, starts to change something very radically about the whole notion of housing production. Here's another one made of bioplastic that's being done in Amsterdam. I just want to point it out to you because, again, we're starting to think about really producing full-scale homes, using 3D printing. This is another example. I actually showed this last year, but I still love it. It's this notion that not only do they have to be those simple little houses, Dr. Koshnivas at USC is actually using this contour crafting large gantry to spread out these fiber cement-like materials to go through and create a 2,500 square foot house. That's quite a large home in 24 hours. And with that, it's not only that it's happening so quickly, but within the wall voids, there's already space for the electrical, the plumbing, the utilities to be installed. And as we get better and better 3D printers, we're actually going to start seeing those things printed as part of the process. So as opposed to putting the wiring in a house or the plumbing in the house after the fact, you like to have it printed as part of the house. And I think that's just where this is all going. And it's going to really radically change. We're moving from a world of assembly of pieces to actually being able to print them directly. So another construction example, I like this one, I wanted to share this one. We always think about 3D printing in terms of these big gantries that move around XYZ. Having teams of robots working together is really kind of very interesting. Getting them into coordination so they can work to create things in unison of almost any arbitrary shape is really very good. Okay, a couple other interesting applications we want to share. There's this whole notion of bioprinting human organs. You may have heard about this. This is incredible research that's going on here. The idea that now, with the incredible precision of 3D printing, we can print out vascular systems, the blood vessel systems to feed organs, and actually work with biomaterials, things that are made of human stem cells to print things like ears, organs, livers, kidneys. It's really just opening up the doorway for much more efficient drug and vaccine testing and eventually transplants for human. So it's going to be really an incredibly wild world. Another project that I wanted to share with you just has to do with manufacturing of 3D printed circuits. And this one's sort of very interesting to me. This was actually done as a Stanford D School project by a student team. And they were looking at the whole notion, could we print full devices? So print not only the base material, but actually the electronic circuitry in a single pass. And if you could start to think about this, as opposed to something like that new iPhone that people stayed up half the night trying to order and have available to them coming through a whole distribution system, the idea that that could actually be printed from a website and printed on your local printer, without a whole supply distribution chain, really just opens up an incredible world where the whole notion of how we manufacturing things could really be turned on end. Okay, the notion of 3D printing instruments is very interesting in terms of both how you do it, but also how people are creating new designs and sharing and crowdsourcing them. The idea is really it's opening up a whole new economy based on people sharing objects. And there's several business trends I'll finish up with that are just kind of really bringing this all together. You know, the world of 3D printing has been somewhat complicated by the fact there's so many different printer formats. They're working a little bit differently. Autodesk has just introduced a fantastic new open software platform called Spark, and it will really make it much easier from any software package to be able to print standardly to any printer. It's, if you can remember back so far, about the same effect that it had when PostScript was first introduced for 3D or for printing, for laser printing, and how it simplified and made that kind of technology available to all applications, or like using the Android OS for smartphones. So there's two pieces to it. There's this whole notion of an open software platform, and Autodesk is supplying that freely to anyone to be able to work with, as well as they're producing a reference printer, which you can see a picture of right there, that will actually demonstrate some of the capabilities. Not that Autodesk wants to be in the hardware sales business, but they're demonstrating and want to push the boundary of really the types of capabilities available through 3D printing. Now, 3D printing is changing pretty rapidly. I also want to point out there's a rapidly changing business climate, and you're seeing this big disruption because different players are offering new services. There's this whole notion that, for a while we thought that everyone would need a printer in their own home, but that's not the case anymore. The idea that you could go to Home Depot or to Staples, those are sort of office supply and home supply warehouses, DIY warehouses, and print there. Or even the notion that Amazon's opening up the capability to now start printing different devices that you'd buy online that would then be shipped to you is really radically changing the whole notion. You don't need your own 3D printer to be able to do things like this. Other people are getting into it, and I think you're going to see a huge disruption in the whole marketplace right now because 3D printing is going to become much more readily available. There's also a very important trend that gets to the whole notion of crowdsourcing, that there's new marketplaces opening up where students, people, folks working from home, retirees, they could all be designing 3D objects, placing them out in marketplaces and selling those designs to be 3D printed. And this is leading to some pretty radical changes into the whole marketplace of how really designs are created and ultimately manufactured, because just about everyone get involved in it now. So finishing up, there's really, I'd say looking forward, there's really a couple big megatrends I'd really like you to be aware of and kind of think about as we move forward with this whole thing. In terms of the whole notion of how can we do this better, the biggest thing I think to really watch out for is that replication really is a reality right now. The whole notion that you can scan it, change it if you need to, and make it is here. That's actually happening today. The software tools, the hardware tools are available. That's actually has to watch out for it. You're going to see more and more of that where people will be replicating things very much like sci-fi. On the augmentation front, in terms of what more we can do, I think the biggest trend you're going to see in the next few years is really this whole notion that 3D printing is going to move from a prototyping kind of planning stage to actually real production. You'll see full-scale production. You'll see prefabrication of real assemblies, and especially use of the 3D printing for complex assemblies, things where we need to have a complex thing that would be hard to produce or couldn't be produced without 3D printing, or we need the reliability. Something about the 3D printer can do it down to that thousandth of an inch in a way that a lot of like hand assembly cannot do. And finally, on the transformation side, this I think is going to be the biggest change, because this is really where the strategic biggest opportunity is. I think there really is this whole notion of democratization of design and production, that everyone has ready access to design and fabrication tools. There are new marketplaces that are crowd-driven, that are very easy to enter, and it's really this trend that's really going to allow, just that next generation to be very actively involved in imagining, designing, and then ultimately making that better world. So that's really where I think this is all going. It's really going to just change the way we do design, and it's really going to lead to a much better world, because as opposed to a few players being able to do this, just a large number of people can do this, and the best ideas will surface and really lead to sort of a much better design, that's ultimately going to improve the way we work in the world and solve some problems that we haven't been able to do in the past. So that's kind of it in terms of a really high level view of it. I would love to kind of like discuss this and answer any questions you might have, but I think that is a starting point or some of the big highlights I'd like you to kind of be thinking about or looking forward to, and hopefully we'll see how those test out in the next year.
Great. Well, thank you very much, Glenn. Have a round of applause, Glenn.
Oh.
You can hear that. Unfortunately, you can't see the people here in the chat here. So, any questions anyone would like to ask Glenn at this stage? Question, yeah?
It was very briefly mentioned around software. There's already changes that's making it specific that you're seeing in the market.
Okay, Glenn, you might not have heard about that, but the question was around software. And is there any changes in software to make it easier for the layperson, the average person in the street, to be able to pick up design tools and learn them so they can start designing and creating their own 3D models?
So in terms of that, there's really a lot of very good software tools, including many what we'll call consumer apps. So Autodesk has actually been very big in terms of saying, let's take a lot of the capabilities that have traditionally been in the very high-end design tools that manufacturers are using, and really even making them available on things like iPads or through the web, so that anyone, elementary school students, secondary students, just home hobbyists can go ahead and use those. There's even a very interesting piece of software I'd recommend everyone look at. It's called Fusion 360. And for any hobbyist, anyone who is just interested in manufacturing and making things, it really is the Cadillac of tools for being able to get design assemblies, put them together, and ultimately manufacture them. And they're all available for free. And that's really pretty amazing.
Yeah, thanks, Glenn. So to reiterate on that, so in Australia and New Zealand, as of August 7th, we now provide all of our professional software suite free for any school, university, and that's at our industry level software. And we've got a lot of training materials and curriculum materials so teachers and students can learn that. But as Glenn said, we've actually now gone down to the app level. So with 123D is a very simple tool to create a 3D model. And I've had teachers ask for training, but after they've actually looked at the app, I said, well, we don't need training. It's very simple, intuitive. There are training videos, but it's actually a nice, easy way to get started. So we have our booth just around the side here, so if you do want to come later, I can show you Fusion 360 and 123D and a few of those other tools and where to locate those training materials to get you started. Yeah, we have quite a lot there for you. Any other questions? No? Pretty.
All right, we'll say thank you again.
Thank you, Glenn.
Oh, my pleasure. Thank you for having me again.